Okay, I hope my screen is visible to you.
Yes, sir.
Okay, so we will continue now. Sorry. All right. Uh, so we will continue now. Yes. Fine. So in the previous class, we have completed the top dome, top ring beam, then circular girder, and the corner. Okay. Then now the only part remaining, which is of this pump house, is the floor slab and the floor beam. Okay. So on the right hand side, you can see a picture wherein you can see the arrangement of beam in the floor slab. So here you can see there are two beams which are installed on the floor slab, and the semicircular slabs are provided on both the sides. Okay. Inside there is a straight opening of 1 meter width, and this opening is provided for installation of pump as well as on the installation of pipe. Okay. So in this case, what we are assuming first is the thickness of the slab. Okay, because we have to do the calculations of design of slab. So as far as this figure is concerned, the maximum, or rather the diameter of the slab is 6 meters. So based on this 6 meters diameter, we are taking a judgment, and accordingly we are assuming that the width of the slab or the thickness of the slab as 150 millimeters, and then width of the support. So here you can see, if you see this portion. Okay, so I'm talking about this portion. This will be a slab. Okay, so this portion will be your slab portion, like this. Okay, so this slab is supported by beam, okay, as well as the well. Okay, so there is a jack well below the pump house. So we are assuming the width of the support on which the slab is resting as 230 millimeters. Okay, so if you calculate the effective radius, so the if you remember clearly, the clear diameter is 6 meters. Okay, so the radius will be, of course, 3 meters, and if you calculate the effective radius, that is the center of this circle shaded portion, that is the jack well. So it is having a thickness of 230 mm. So if we calculate the effective radius, so you can see in this figure, so effective radius is exactly the half of this thickness of the slab. ठीक है, यहाँ पर आएगा ये. ठीक है. So this is distance is nothing but 3.115 meters. Okay, so now if you see the span. Okay, so span is nothing but this one. So this should be designed as a one-way slab, and it will be bending along the shorter side. Okay, so since it is bending along the shorter side, so the span of the beam will be nothing but 3.115, which is the effective radius, minus half the opening. So the opening, we are assuming that the opening is 1 meter. So the span of the slab comes out to be 2.615 meters. Okay, so this will be the effective span of the slab. Okay, so it is already indicated in the figure. So now quickly let us go for the dead load. So dead load is nothing but thickness into the density of the concrete. So here the thickness of the slab, we have already assumed this as 0.15 into density of the concrete is 25. So how much is this? 3.75. This will be kilonewtons per meter square. Okay, now live load. So this is a very important structure, and you may find many of the heavy loads like pump and other pipe fittings, they may be kept on the slab. So accordingly we are assuming the live load on the slab as 5 kilonewtons per meter square. Okay, we are also assuming a floor finish of 0.5 kilonewtons per meter square, which is there on the circular slab. Okay, so the total load comes out to be something like 3.75 plus 5 plus 0.5. How much is that? 9.25. Okay, so the total load which is coming on the slab is 9.25 kilonewton per meter square. Okay, so this is the total load which consists of dead load as well as light load. Okay, so now for this much of load we have to now design the slab. Now remember, this slab is basically D kind of a shape, semicircular shape, and definitely we have to design it in such a way that it will be sagging in the shorter direction, okay, not the longer direction. So your main reinforcement will be provided along the shorter side, and along the longer side it will be distribution reinforcement, and the main reinforcement has to be kept below and the distribution reinforcement should be kept above. Okay, तो जितने छोटे बार रहेंगे वो नीचे रखने हैं और डिस्ट्रीब्यूशन वाले बार ऊपर रखने हैं. तो मेन बार नीचे रखने हैं. हाँ, वही मैं बोल रहा हूँ, मेन बार विल बी डाउनवर्ड. So now, if you see the cross section, it looks like this. Okay, so this will be a slab which will be having one end, there will be a beam. Okay, so you can see the slab is resting on the beam, and on the other side it is resting on the well itself. Okay, in both the cases we have assumed the thickness of the well as well as the thickness of the beam as 230 millimeter. Okay, so based on this, now we have to calculate the bending moment. So bending moment, we are using a simple expression, that is WL square by 12. So this is nothing but a beam which is having both end fixed. Okay, and this bending moment will be there at the top, not at the bottom. Okay, so at the middle portion the bending moment value will be even lesser. Okay, so if you use this expression, so your W value is 9.25 बराबर है. Okay, into L square. So the span we are assuming, or we have already calculated as 2.615. So this is 2.615 square. How much is the bending moment then? Someone please tell me. W square by 12. बोलो भाई जल्दी बताओ. कितना आ रहा है? Come on, do the calculations quickly. बताओ ना भाई, बेंडिंग मोमेंट कितना है? 5.27. So it's a very small value, 5.27 kilonewton meter. Okay, so accordingly now we have to calculate the depth of the slab which is required. So the moment of resistance is nothing but the bending moment. This is what we are assuming. So this value is 5.27 into 10 to the power 6. What will be the value of Q? पहले हमने calculate किया है. I think the Q value is 1.527, right? So this is 1.527. B value, since this is slab, so this will be 1000 and D will be unknown. So can someone tell me what will be the value of D which is required? It's a very small value, isn't it? So this is 58 point something mm. Okay, so looking at the importance of the structure, we can reduce this. Okay, we can reduce this to 100 also, but you see it will be heavily loaded. Okay, impacts will be there, so it is better you provide on the safer side. Anyway, it's a very small kind of a structure, so economically it won't be costing you much. If you provide in place of 100 mm, if you provide 150, it is not going to cost you much. Okay, so what we will do, we will go for the basic assumption. We'll continue with the basic assumption, that is the D value. We are taking this as 150, and if you take a clear cover of 20 plus diameter of the bar, let us say 10, so we can have the total depth as here as 150, and this depth we can have something like 125 millimeter. This is going to solve our purpose, isn't it? Now, let us quickly calculate the AST value. Okay, so the AST value, it will be relatively less because bending moment value itself is very small. So bending moment value is something like 5.27 into 10 to the power 6. So sigma st has to be taken as 130. Your depth has to be taken as 125. And I think J value, let me go back. I think J value is 0.86, right? So this is J value is 0.86. How much is this AST then? Yes, someone please do the calculations. Sorry? 377. Okay. And how about AST minimum? That is 0.24% of the cross section area. 360. Okay. So definitely we are going to provide the maximum value of 377 millimeter square. So if you provide 10 dia bars, so what will be the spacing? 208. So 208 is basically greater than 150, which is the thickness of the slab, है ना? So it is better, in place of providing 8 mm to 10 dia bars, you provide 8 dia bars. What will be the spacing of 8 dia bars? 149. Okay. So okay, कितना आ रहा? 133. Okay, so this is 133, right? So what we can do is we can provide 125, which is even smaller than the thickness of the slab. Okay, but this reinforcement has to be provided as at the top as well as at the bottom. Okay, not only on one side, you have to provide this at the top as well as at the bottom. So I am talking about, if you refer this particular figure, so this main bars, this will be something like 8 dia at the rate 125 center to center, as well as this main reinforcement, this will be also 8 dia at the rate 125 center to center, both way. Okay, how about distribution steel? Distribution steel is 360, that is minimum AST. So it comes out to be 360. So 360, you can provide 10 dia bars or you can provide 8 dia bars. So we can keep the same thing, 8 dia bars. So the same bars, so these bars, okay, I'm talking about these bars. So this bar as well as this bar, you can provide this also 8 dia at the rate 125 center to center. Okay, it's a very small structure, but it has to be, it should sustain all kind of loadings. Okay, so we are going for over reinforced structure over here, but it is essential at this stage. Okay, I hope this is clear to everybody. Okay, any queries? Okay, so moving on to the next topic. Now we have designed the slab. Now let us design the beam. Okay, so you can see in this picture the two black lines. Okay, they are nothing but the beams. So now we are going to design the beam, and we have already assumed the width of the beam as 230. Okay, the same we have assumed while the design of slab. So now this time I am assuming the depth of the beam at 600 mm. Okay, I am slightly going on the higher side, you can provide even lesser also, but later on we'll have to check whether it is sustaining or not. Okay, so now we have to just see the load calculation now. So the very first load is nothing but your self weight, that is B into D into density of the concrete. So your B value is 0.23. The D value, let us, in place of small d, we can take capital D also. and this is 25. How much is the dead load now? Yes,
3.45.
3.4. 3 point something? 45. Okay, this is kilonewton per running meter, right? This is a self weight, right? So if you refer the figure which is on the right hand side, so this is basically a fixed beam. Okay, both ends are fixed and it is subjected to a simple UDL. This UDL is only due to the dead load. So based on that, now you can calculate the shear force and bending moment. Shear force will be simple, WL divided by 2. Now what L you have to take? You can calculate the
Dia.
actual length. Okay, actual length will be slightly lesser than 6, because if you see the length of the beam is the beam is located slightly, or rather I should say specifically 0.5 meter on the right or on the left of the center line. Okay, तो उसका जो लेंथ है वो 6 से थोड़ा कम आएगा. ओके, सो इन प्लेस ऑफ डूइंग दिस वी कैन डायरेक्टली टेक 6. दिस इज गोइंग टू give you slightly increased bending moment, which will be definitely beneficial for us. Okay, so no need to do the exact calculation. You can always take the length as 6 meters. Okay, so if you take this length at 6 meter, this will be a clear span. Okay, so the effective span will be plus half of the width of the support from both the sides. So your L value will be plus 0.23. So this will be 6.23 meters. So here the value of W is 3.45 and this is 6.23. Okay, so now accordingly give me the value of bending moment and give me the value of shear force.
10.35.
Sorry, yes, 10 point
11.15.
11.1 kilonewton meter. And bending moment, oh sorry, shear force, my mistake, 10.75 kilonewtons. Okay, so now these are the bending moment and shear force due to the self weight. Okay, now since the beam is supporting some portion of the slab, because if you see the slab, it is D kind of a shape. So some portion is resting on the beam and some portion is resting on the jackwell itself. Okay, so we will see that one also, but before that let us go for the pump. So here in this picture you can see pump will be installed on the beams itself. Okay, so number of pump depends on your requirement. If requirement is more, you can provide 2 pumps, otherwise you can provide only 1 pump. Okay, so this pump specification will be known to you, right? So depending on the specification, you can know how much will be the weight of every pump. So in the exams or in the real design, you have to calculate this. Okay, in examination these values will be given. So as far as this problem is concerned, let us assume there are 2 pumps which are installed. Okay, so they are installed at equidistance. Okay, दो पंप एक साथ चिपक के सेंटर पे नहीं लगाते हैं. Okay, so there has to be given some spacing. So usually it is equidistance and it is supported or it is resting on both the beams. ठीक है, एक ही बीम पे नहीं जाता है. ठीक है, so as you can see in this picture, right? So let us assume the weight of each pump is 20 kilonewton and there are 2 pumps and it is placed equidistance and the impact factor is 25. This is what I am assuming, right? So if you consider the impact factor of 25, so the weight of every pump, or rather the reaction of every pump on a single beam, okay, it will be 20 into 1.25. This is due to the impact, divided by 2. Why I am going for divided by 2? Because the pump will be resting on this beam as well as that beam. 2 beams are there. Okay, so it comes out to be 12.5 kilonewton. So if I draw this beam figure like this, okay, only one beam if I draw, so it will look like this. So you will have a load of 12.5 and 12.5. It is located at equidistance. Okay, So the span of this particular beam is 6.23. We have already calculated. So this is 6.23. So you have to divide this into three equal parts. So it is not exactly possible. So we are taking on the left hand side 2.07, on the right hand side 2.07, and in the middle 2.09. Okay. So now if you do this calculations, so you are going to get the maximum bending moment, which is over here. Okay, and maximum shear force over here. Okay, so maximum shear force is nothing but Ra, that is the reaction at end A, assuming that this is A and this is B. So this will be same as 12.5. Okay, half of the load will go here and there. And if you do the calculations of bending moment, so at this section, if you take a bending moment, this will be 12.5 multiplied by 2.07. So bending moment at this section, let us say this section is XX. So this section bending moment value is 25.875 and the shear force will be 12.5. Okay, I hope this is clear to everybody. A simple EM problem. Okay, so now we have now two bending moment values and two shear force values. One is with the self weight of the beam and the second one is due to the weight of the pumps. Now the third part comes, that is the weight of the slab. So on the right hand side picture you can see this is the exact slab. Okay, so the length of the vertical portion is 6.3 meters, sorry, 6.23 meters, which is shown over here. And this diameter, okay, from here to here, this distance is nothing but 2.615. So what I am doing is I am taking the average of this. So average of this, it comes somewhere over here, and the value is 1.3075. Okay, so the shaded portion which is shown in the figure, so whatever load which is acting on that shaded portion will be taken care by the beam. Okay, and the empty portion, it will be transferred to the jackwell. Okay, this is how we generally go for load distribution on the slab. So if you take the UDL, so we have already calculated the UDL and the slab as 9.25. Okay, if you go back, so I think yes, we have calculated over here. This is 9.25 kilonewton per meter square, right? So this is 9.25 kilonewton per meter square. And if you calculate the area of the shaded portion, so area of the shaded portion is basically, it's a triangle. So you can go with the height of the triangle multiplied by the width of the triangle divided by 2. So this is the pressure intensity, okay, and this is the area. Okay, so this is the area. So this is the total load. So this will be the total load of the shaded portion, which is triangular in shape. So now there are some standard equations. So let us say we have a beam which is like this. Okay, and there is a, sorry, this is a triangular portion. Okay, so triangular portion is like this, and if you convert this triangular portion into a concentrated load which is 37.68 kilonewton, so for such condition the values of shear force and bending moment can be calculated in this form. Okay, so shear force is exactly half of the total load. So half load will go over here and half will go over here. As far as bending moment is concerned, bending moment can be calculated by a simple expression, 5 by 84 capital W into L. So where this capital W is nothing but the total load and L is nothing but the span. So span is nothing but 6.25. So let me write down these values over here. So this capital W is 37.68 and the span is 6.23. So with this you can get the bending moment value as 24.25. Is it correct? And the shear force is exactly half of the total load, so that is 84.48. Okay, now I think we have already covered every loads. We have covered the self weight, we have covered the slab weight. These comes under the dead load, and we have also considered the weight of the pumps. So now there are three values of bending moment and three values of shear force. So all we have to do is just add them. Okay, give me the values of total shear force and total bending moment. सर क्लास में बाद में बात करता हूँ। सर सर क्लास में हूँ, बाद में बात करता हूँ, बुला करता हूँ, ठीक है। हाँ, टोटल बेंडिंग मोमेंट कितना है? तीनों वैल्यूज ऐड करो बेटा। I think this is 24.24, sorry, 24.45. This is 24.45 and 18.87, sorry 18.84, और इसके पहले का है 25.875, 25.875, and the shear force is 12.5. Okay, and previous to that, I think we have bending moment as 11.16 and 10.75. 11.16 and 10.75. अब बताओ
So 61.48.
बेंडिंग मोमेंट. Yes, someone please check. बताओ भाई. 64.48 है, मैंने 61 लिखा है. 61 ही है, ठीक है. और शेयर फोर्स कितना है?
42.
42 एग्जैक्टली.
0.09.
ठीक है, जो भी है. Okay, so now this is the combined effect of everything. So now we can calculate the effective bending moment, because this is a D kind of a shape, and because of that some load will be slightly reduced. So the effective bending moment will be bending moment minus shear force into width of the support divided by 3. So bending moment is 61.48 minus shear force is 42 into width of the support is 0.23 divided by 3. How much is this? This will be very slightly reduced.
58.26.
58.26 किलो न्यूटन मीटर. ओके, ये बहुत थोड़ा सा कम होगा. ठीक है. ना अकॉर्डिंगली नाउ वी हैव टू डू द डेप्थ कैलकुलेशन, फॉर विच इस क्यू वैल्यू आई थिंक 1.2 कितना देखा मैंने. Q value is
1.5.
1.527, right? So this is Q value is 1.527. Your B value will be 0.23. Okay, D will be unknown. Effective bending moment is 58.26 into 10 to the power 6. How much is the effective or the required depth now?
407.28.
Yes, anyone? 407 is one answer. 401. ठीक है. And how much we have assumed? We have assumed 600. Okay, so we are in the range. अगर तुम चाहो तो इसको 500 से भी कर सकते हो. ठीक है. 407. ठीक है, doesn't matter. So we will continue with this depth as 600 only, the total depth. Okay, and we can assume the total depth as 600, and if we assume the 10 mm die bar, so effective depth will be 575 millimeters. Okay, so now based on this, now we have to do the AST calculations. So for AST calculations you need a effective bending moment. So effective bending moment is 58.26. Okay, so this is 58.26 into 10 to the power 6. Sigma st is 130. J I think 0 point कितना है? 86. Okay, and D value is 575. How much is this?
900, 9006, 906.
Yes.
Yes, sir.
No. Now, according to IS code, the AST minimum for beam should be 0.2% of cross section area. So we can have this. How much is the AST minimum?
276.
276. ठीक है. So what we can do, can we provide 3 bars of 12 mm dia bars? How much is the cross section area? Someone please check. Is it greater than 906? 12 के 3 बार. 3 नहीं हो रहा है. 12 से 9 बार्स. ठीक है.
8 बार भी चलेगा.
सॉरी,
8 बार भी चलेगा.
एग्जैक्टली कितना लग रहा है?
8.01.
8.01.
01.
देयर इज नो पॉइंट. हाँ, 16 चे 5 करा. ठीक है. सो वी कैन प्रोवाइड समथिंग लाइक 16 डाया और रादर 5 नंबर 16 mm डायाबॉल्स. ठीक है. AST इसका कितना आ रहा है? हाउ मच इज इक्विवेलेंट AST? 1005 mm square. ठीक है. सो नाउ दिस हैज टू बी प्रोवाइडेड टॉप एज वेल एज एट द बॉटम. ठीक है. सिर्फ ऊपर नीचे यानी रेगुलर बीम के जैसा नहीं करना है कि सपोर्ट पे अलग इस पे अलग, वैसा नहीं करना है. ओके, दिस हैज टू बी प्रोवाइडेड एट द टॉप एज वेल एज एट द बॉटम. ओके, so here let me check this. So this will be 5 numbers 16 dia. This will be also 5 numbers 16 dia. Okay, so now quickly just check for the shear. So we have already calculated the shear force. The value of shear force, I think it is 42 kilonewtons, right? So this is 42 into 10 is to power 3. Your B is 230, D is 575, or you can have now, since the diameter of the bar is there with you, so this is 25 plus 8. थोड़ा सा कम आएगा, right? So effective cover you can deduct from capital D. How much is the tau V?
0.31.
Sorry,
0.31.
0.31. And your AST is 100 into AST provided is 1005. Just now we have calculated. So this is 230 into 575. How much is the percentage of steel?
0.75.
0.76%.
76.
Okay. Accordingly, now we have to check how much is the shear force permissible. Yes, anyone has a IS code? है IS code किसी के पास? Otherwise I will have to open the IS codes. It is 0.76, so let us keep 0.75. Okay, so for 0.75, the tau c value for M25 grade concrete, I can see it is 0.36. Okay, so let me go back. So this value is 0.36. Okay, so I don't know why, but your tau c is greater than tau v. ठीक है. So now you don't have to worry, your beam is safe in shear, but still we have to provide the nominal reinforcement as per the standard course. Okay, so that part you can do. So if it is not there, then we have to follow this we have already discussed. Okay, so shall I continue this? ठीक है. एक small part बचा है, that is the design of walkway. Okay, So on the right hand side topmost portion, we can see a walkway is provided for examination purpose. So just to see whether everything is well or not. So you can just walk around the structure. So for this, what they do is they provide a simple cantilever slab. Okay. Now this simple cantilever slab will be an extension of the floor slab. So it is casted along with the floor slab, and usually it is 1 meter length. Okay, 1 meter से ज़्यादा नहीं होता है. And on this parapet wall or on this walkway, they generally provide a steel railing. Okay, there is no brick wall. Okay, if there is a brick wall, then we have to consider the load of brick wall as a concentrated load which is acting at the cantilever portion. Okay, but usually it is a steel railing. Okay, so if it is steel railing, no need to worry about the dead load. Otherwise you can consider the brick wall load. So it's just a simple design. So what we can do is we can assume the thickness of the slab as 100 mm. What you can do is, if you see the floor slab, so floor slab is basically 150 mm thick. Okay. So if you wish, you can provide a continuous 150 if it is required. Okay. Otherwise, usually 100 mm is sufficient. Okay. And you have to keep the reinforcement in line with the main reinforcement, because यही reinforcement जो main slab के है वही बाहर जाएंगे. ठीक है, otherwise there will be a overlap. So we can assume the length of the span or the span of the cantilever slab as 1 meter. You can quickly see the dead load. So if you consider the thickness of the slab as 100 mm, so the thickness will be 0.1, density will be 25. So this is going to give you 2.5 kilonewtons per meter square. Live load, yes, you can assume a higher value of live load. You can assume 3. Floor finish can be 2.5. Floor finish can be 0.5. So the total load, that is 2.5 plus 3 plus 0.5, that comes out to be 6 kilonewton per meter square. So this is a simple cantilever slab. So the shear force will be W into L. So this will be 6. W will be 6 into the span will be 1. So this will be 6 kilonewton. And your I think I have written, yeah, I have written correctly. This is W into L by 2. So this is 6 into 1 square divided by 2. So this will be 3 kilonewton meter. Okay, it's a very simple cantilever slab design. So I think this will be sufficient. Okay, so your Q value, I think it is 1.527. B will be 1000. D will be unknown. This moment of resistance is nothing but your ये कितना है 3 है नहीं क्या 3 into 10 to the power 6. This value will be definitely less. कितना आ रहा है बता दो
44.32
44.32 millimeter, no, only millimeter, not square. Okay, so definitely we can have 100 mm. Here we can have 75. So bending moment value is 3 into 10 to the power 6. Sigma st is 130. J is 0.86, and D will be something like 75. How much is this? Also calculate the AST minimum, that is 0.24% of the cross section area.
357.
Sorry?
357.
357 mm square. How much is the AST minimum?
240.
Sorry?
240.
240 mm square. Okay, fine. Now we have to provide this steel at the top. Okay, because it's a cantilever beam. So what we can do is we can provide this as main and this as secondary steel. Barabar? But now before going for the actual bar calculations, we just have to go back to the design of slab. Okay, now if you remember, in the design of slab we have provided the bars at the top at 8 mm dia bars at 125 millimeter center to center. Okay, so what we can do is we can extend the same bars. Okay, but if we extend the same bars, whether it is satisfying the AST requirement, that is 357, चेक करो कितना आ रहा है. 8 mm dia bars at 125 center to center is equivalent to how much of steel? 402. So if we provide 8 dia at 125 center to center, this is 402 millimeter square. And how much we require? 357. So yes, we can extend the same bars. There is no point. Okay. And as far as secondary steel is concerned, so we can provide the same secondary steel. Okay. Hardly 1 meter ka span hai. So if you want, you can do the calculation of this for this 240 mm square. Okay. So if you provide 8 dia, spacing कितना आएगा 8 dia में 240 में. If your AST is 240 and if you provide 8 mm dia bars, how much will be the spacing? 209. और हम लोग वैसे भी थिकनेस से ज़्यादा नहीं देते. ओके, सो वी कैन गो फॉर 8 at 125. ओके, सो दिस वे वी हैव टू सी. ठीक है, ऐसा नहीं है कि यहाँ का स्टील अलग और वहाँ का स्टील अलग, वहाँ पे एग्जीक्यूशन में बहुत प्रॉब्लम होती है. ओके, सो वी हैव टू टेक केयर ऑफ दैट वन ऑल्सो. ओके, so we have completed this. So now we will continue in the next class with the design of jackway. Okay, so are there any queries as far as this part is concerned? So I'll upload the word file, or rather the PDF file of this entire pump house. ये जो पूरा PPT है, it is roughly probably कितना है 36 pages, so that I will upload in the Google Class. Okay, so we will stop here. Let me quickly take your attendance. Okay, let me stop the recording. Okay.